It was one of my childhood dreams to build an analog computer, and now that dream has finally came true. You may be wondering how I arrived at this point, and my answer is I started with research, as I did with every project in the past. While doing so, I came across this great online library. 3 papers by Dr. Vogel in particular immediately fascinated me. Among them was a circuit diagram for an analog computer, which I used as a starting point for my own design. After weeks of studying datasheets, calculations, circuit layout, and design work, I sent the Gerber files to GLC PCB and received this beautiful PCB a week later. Like any analog computer, mine also consists of the 4 following main building blocks. It took me a full day to populate the PCB. I have always liked the Polish analog computer AKAT 1 from the 1950s, which is why I based my enclosure design on it. The enclosure has a modular design and was also 3D printed by GLC PCB. Unfortunately, there were strange residues on the surfaces. Of course, the 2 analog voltmeters of the AKAT 1 were a mandatory feature. They can display positive and negative voltages. And of course, my analog computer also had to have an oscilloscope as a screen. I opted for the affordable entry-level oscilloscope DSO138. Finally, I got rid of the milky residues on the resin by cleaning everything with isopropanol and then treating it with cockpit spray. Before I could mount the PCB, I had one more tedious task to complete. Over 100 2mm banana sockets had to be installed. Did you know that there are around 10,000 neurons in 1 cubic millimeter of the human brain connected by 3 kilometers of wires? Analog computers are also programmed using wires. I made them myself. The ready-made cables you can buy are usually rubbish. The great thing about these banana plugs is that they are stackable. In addition, I made a pair of cables with 4mm banana plugs on one end, so that the computer can be connected to a multimeter, and I also wired a push button for triggering. After so many hours of work, it was finally time to power up the computer and run some tests. The machine unit of the computer is plus minus 10 volts. Here you can see me testing the function generators. They are used to study dynamic systems. And here I have wired one of the summing amplifiers to perform the addition 5 plus 4. The sum, of course, has a negative sign. With a multiplier you can perform quite complicated calculations. I limited myself to squaring the number 5. The result of the multiplication is always divided by 10. Since I plan to build a neuromorphic computer, I will conclude by showing the input stage of a leaky integrate and fire neuron, for which the integrator is used. What can be seen on the oscilloscope is a solution to a linear inhomogeneous first-order differential equation. Unfortunately, that is all the time I have for you today. Thanks for watching. Stay true, stay you.